First of all, thank you for giving me the opportunity to take part in this interesting session and to present some of the work and thoughts we are concerned with here in Germany. So I'm located in Germany near Koblenz, which is halfway between Cologne and Frankfurt, if you have an idea of the map of Germany. So what I want to talk to you grow out of some workshop which we had here on March 20th this year. It was organized by the virtual campus of the German land Rhine-Palatine, and it discussed issues of the influence of generative AI on STEM studies in higher educations. And there were several questions discussed at this workshop. And one of them, which somehow leads to what I'm going to talk about now, is should we teach students the use of AI tools? And there were really different opinions there. And what I'm telling you here is just my personal opinion. And I would like to emphasize that this is not necessarily endorsed by any of the organizations I work with or by all of my colleagues. So some of the colleagues think that, well, teaching AI competencies and the use of AI tools is not our job. We are teaching math and physics and engineering or whatever. But I think that's wrong. And since, well, somehow we are preparing students for their job career after their studies, and certainly they will be using AI tools there. And if we don't teach them how to use them, they will be less performant, and there will come others, probably private agents, come up with teaching them these things, or industry will teach them, and certainly with a less background from the subject we are teaching, which is important for the use of AI, as we will see. That if we agree that we should teach students the use of AI tools, then the question is, where should we do this? And there are some natural possibilities that come to mind. We might offer special courses for using AI tools. We might do that during the bridging courses, which we offer to beginner students, and or within courses on scientific writing that we offer at the beginning. But the big disadvantage of all these approaches is that they are all voluntary here. So we note that those students who need them don't take them. So you can't rely that the students acquire the necessary competencies in such courses. So the only remaining alternative is that we integrate the teaching of AI competencies in the ordinary courses. This has some consequences for the staff, which I won't discuss here, but what I just want to report on an experiment and how this might be done. And to test this, I'm using a bridging course, well, knowing that this is not the right spot to do it, but it's interesting because it covers many areas, and for an experiment, I think it's fine to try that out. And fortunately, I had some material prepared, which I named the bridging course for the curious and lazy, which had developed from a static bridging course documents consisting of PDF documents with interactive online test questions and videos added, where we use the central online test system, which the virtual campus Rhine-Palatine offers for all public universities of the land, which is IMATH-AS, which is similar to Nimbus, which is more known in the UK. And there was also added access to online computer algebra systems, so that these systems could be used in the, for solving the problems from the online test systems. And in that earlier experiment, it was found out that about 20 commands on the system Sage Cell is sufficient to solve about 80% of the standard questions automatically. Of course, you have to learn the syntax and the usage of the computer algebra system, but on the other hand, you save a lot of time by typing in questions and doing tedious calculations, and which are also error prone. So now the new step now was to test this with AI. how does it behave when you hand over these questions to the AI, and what could we learn from such an experiment? So I was using an AI system that is easily accessible, that is free and easily available, and that's advanced. And I choose to use ChatGPT-4 in the format of Microsoft Copilot, as it's integrated in Edge. It's free, and you can use it easily. I did this experiment in April and May 2024. It may change, the results may change half a year from now. And from the setting I used, it required it to be precise, so working with a low heat. So, of course, one of the biggest problems is that students need to learn the critical evaluation of AI answers, and they often lack the competency to do this. So a way of teaching them this would be for the teacher to discuss wrong AI answers. So in this course, I spotted 31 wrong AI answers from all of the fields of mathematics, reaching from fraction calculations through calculus, vector calculus, geometry, up to combinatorics. And in this discussion, I tried to find out techniques to teach the students to evaluate these AI answers, to find out whether an answer is wrong, and if it's wrong, how it can be corrected, and what AI is good at, and what they should use for it. So as a summary of findings, I found out that the AI, indeed, in this version, which is not the most advanced one, can solve many of the problems in the bridging course, including word problems. And in particular, it's often good in finding the right approach to solve a problem, even if it doesn't provide the right solution. And so I think this is very, very promising. And so the next thing I'm currently working on is to augment our online math test system with the chatbot that helps students finding the right approach to solving problems. So this AI is unreliable when doing symbolic or numeric calculations. I know that there are better ones, but this is what students will get if they don't want to pay. And sometimes it even refuses to do calculations. It tells you, I'm an AI, I can't do calculations, use a calculator or use computer algebra systems. And another good thing about the AI is that it doesn't just present a solution, it provides detailed explanations, which can be checked to spot where it goes wrong. And very often you can use the approach and can correct the solution that it provided. And it also can provide code for computer algebra systems so that you can make better use of computer algebra systems, even if you don't know how to program it. Okay, so the takeaways for students that students could have learned in such a course. First of all, to never trust an AI. So you can't rely on it. And then a quite simple method is to find whether it's trustworthy, to ask it to solve the same problem twice. And if it produces different solutions in a problem which has a unique solution, then you know it's not trustworthy. It's important to check AI answers for plausibility, and there are opportunities in the bridging course to teach how this can be done. However, many of the standard problems are implausible anyhow, and so this doesn't work always. But the good thing is to take away for students, if you don't know how to solve a problem, it's a good idea to ask the AI. It may put you on the right track. And you should try to understand the AI's explanation with a critical eye on it. In particular, you should check the AI's calculation, and computer algebra systems come in very handy at this. And it helps often to request detailed explanations of particular steps. If it can't do a solution, break it down, provided you have the competency to break the problem down. So you can decompose problems and use the technique of chain prompting. So I have some examples here. So it can give a simply wrong answer with a wrong calculation. It can give partially correct answer. Well, there are only finitely many solutions, but it produces an infinite series of solutions, which is obviously wrong, but correct solutions are involved there. It can give some implausible answers here about the inhabitants of some German cities. And you can see that the answer would be implausible. Sometimes here in this case on filling a swimming pool through 3 pipes, the answer of 29 million liter per minute is clearly implausible. But you can get the correct answer with chain prompting if you ask it first to model the situation with an equation system and then to solve the equation system. This is the only case where it got a wrong approach. This is a question from combinatorics and about boys and girls selecting cakes. And it always insisted of solving the problem first for girls and then for boys, which had nothing to do with the problem. A particular problem are visualizations. When I ask it to draw the graph of a function, it comes up with some nice pictures which have nothing to do with the problem. But you can rephrase the problem and ask it to write a Python program to plot the graph. And then you can use the computer algebra system to get a correct solution. So this is, again, the summary of findings. You can use the online test system to verify the answers of computer algebra systems, and you can learn how to make use of it, so how to correct its answers using computer algebra systems. So that's it for now. Thank you for your interest, and I'm open for questions.
Fantastic, thank you, Ingo, and a very well-deserved round of applause there, because I think what you've kind of really sort of encouraged us to do is to think about how we interact with these systems. I think it's their kind of role quite clearly within the learning process, and just asking for answers isn't always one way of doing it. It's how we can use these to help move students towards the solutions. And I thought that integration that you had there was really quite nice. I don't see any questions in the chat, but it would be great if colleagues could think about posting those. But I think I'd be interested in hearing about, you've mentioned kind of a couple of ideas of how you started to use this in a kind of a very pedagogic sense, and the integration with the different tools, so the algebra systems and that kind of pedagogic approach. Where do you think you might extend this next, or what are you kind of thinking for how you would develop this approach further?
Well, the next thing which I'm currently working on is the following. As I said, the AI is quite good in finding a right approach for solving a problem, and this is what students are bad at. They are good at doing some calculations if they have understood the algorithm. This is what AI is bad at. So what I'm currently doing is to extend our online test system, IMathAS, with such an option. I've configured a chatbot which takes a mathematical problem and it tries to put the student on the right track by asking it questions. So, for example, if it gives you the problem to find the derivation of a complex expression, then it may ask you, well, how can you simplify this? What kind of derivation routes might you apply there? And in this way, it should guide this student to finding a question. And we can configure the online tests in such a way that this opportunity becomes only available after the first failed attempt, so the students can't do it themselves. So this is something I'm currently working on, and it's almost working already.
And that's really interesting, because that sort of aligns with the things that Mike Sharples calls the sort of Socratic opponent, where it's not kind of just telling the answer, but it's actually inching the student there through the dialogue, and you want that dialogue to be to very much be two-way. You mentioned that a lot that you were kind of using Copilot as the sort of vehicle, if I understand that correctly. Obviously, that plugs into the GP4 LLM, but was there a particular design choice, given that we sort of seen things like Llama and ChatGPT mentioned? We don't hear perhaps as much of Copilot in some of these discussions. Just wondering what your decision-making process there was.
Well, the reason was to find some advanced large language model that is easily available. Students in Germany don't pay for their education, so they are not willing to pay, and they're using solutions which are not necessarily open source, but free for them to use. And this is one of the most advanced solutions that is free and easy to use them without any installation or any installation hassle. And well, in fact, we are also discussing issues of privacy, but I don't think that they are really important in this case, because you don't really share personal questions in. You're just asking general mathematical questions, and the best thing, well, and moreover, it's the student's decision whether they use it. So we should tell them, well, that then the chatbot will know that you have this question. And of course, if it's integrated with the browser, you may it may identify you. In the long run, if we want to provide tools through the university, we'll have some kind of proxy which masks the identity of the student, so that the leak of personally identifiable information is much less. But in general, I think the dialogue in math with chatbots doesn't contain a lot of personal information.
Yeah, and I was sort of wondering if that was the point, because of Copilot sort of being built into the Microsoft suite that's sort of available to institutions. And I think in doing that, you've raised a sort of a really important point that we should at least acknowledge within this meeting, even if we can't solve it, is the point around equity. That by having Copilot and the institutional release, that gives all students a sort of equal access to one of the best tools, but recognizing there are various iterations of Gemini, of ChatGPT that are paid for, that will have different functionality. And so it's important, isn't it, that equity piece, that students have equal access to tools to use within their learning.
Well, at least here, the Microsoft Copilot comes with every installation of Edge, and you have 30 questions for free in any session of the browser. So that's available to any student.
Yeah, and I suspect that's probably the same here within the UK. I think there is completely free access to Copilot via Edge. I think some institutions have got more unlimited usage, and have that ability that it is a kind of a secure environment, in that information isn't shared with OpenAI. But I think that is an important one to note if people are exploring this, that Copilot does give some good usage for free to all students.
It may be of interest for you, the solution that we have here in Random Palatine for schools. They have a bit different approach. There is a company in Hamburg called Phobis, who provides a proxy towards ChatGPT and other AIs for all the schools in Random Palatine, and doing the maskings. And all the schools here have free access to that. Unfortunately, that's not the case for universities. Every university has to figure out its own solution, and they haven't done that yet.
Yeah, and that's really interesting, given the costing model that underpins that. Ingo, that was brilliant. I think another quick round of applause to say thank you, for bringing on a sort of set of issues of how we think about the pedagogy within this, and how the way you kind of relate it to some other tools as well. I think you've given us a few things to really think about.